My name is Christodoulou. I head the Advanced Manufacturing Office at DOE. I am actually in the greater DOE. I'm part of the energy efficiency and renewable energy component of DOE. I will introduce our panelists in just a minute. But before doing that, I wanted to give everybody a glimpse. First of all, welcome you and ask for your participation in this panel and in this discussion. This can only be productive if you participate with us and share thoughts, ideas, and questions. Secondly, I'd like to sort of give you a sense of where the Department of Energy and the Advanced Manufacturing Office in particular is going with respect to this domain. And I will, somebody can help me put the charts up, which I don't know where they are. Let's see.
Allow you to rehearse.
So, by way of introduction, let me just say that, welcome. By the way of introduction, let me just say that I personally am passionate about manufacturing. And I think manufacturing represents a great opportunity for the United States. It's not only an economic issue, it's a national security issue in many, many ways. A nation that isn't strong economically will have a hard time maintaining a defense posture as well. And although you'll hear you'll see different data, manufacturing constitutes, this was a year and a half ago, since then the GDP for manufacturing has gone up, thankfully. But it employs something like 12 million people are employed. But interesting, I think perhaps that you don't know this, is that 60% of engineers and scientists work in manufacturing. These are the so-called good quality jobs. And as an engineer and a scientist, this is very important and dear to my heart, certainly. With respect to energy and our dependence on foreign oil and other issues of that type, of energy in the industrial sector represents about 30% of the total consumption in the United States. So saving energy in industry is really a big deal at the strategic as well as the tactical level. Now, within the newly formed Advanced Manufacturing Office, we're trying to do a couple of things. One is to help deploy technologies that we know about. These are, in the technical lingo, maybe we'll call them TRL-9 technologies. These are things that have really no technical risk, and the barriers to implementation are really related to the economic case of making the case for them. And that would be the second bullet in my chart here. In addition to that, our goal is to foster, to research, develop, and demonstrate new advanced processing technologies in the manufacturing domain. And I'll show a couple of examples of this by way of making it real for you. But we're really interested in manufactured products, high quality, low cost, globally competitive products that will give the United States industry a competitive edge. That is really what we're looking to invest. And the way to choose how to make those investments with the precious dollars that we have is really quite a challenge. So, let me share with you our mission derives from the President and his Advanced Manufacturing Partnership program that he announced, which is a joint industry government partnership to identify critical investments that we will jointly make, public-private partnerships, in order to provide the United States a competitive edge in manufacturing and technologies. In our specific one, there's clearly defense aspects to this and so on, but our specific domain of interest would be to develop and demonstrate new energy efficient processes. Now, it is important to stress this, that no matter how efficient they are, they will not be adopted unless they are high quality, low cost. Now, that is inherent in our thinking along those lines. And the types of things that we will engage in, and where I would like this discussion to help us with our investment strategy, is to sort of derive from the President's the PCAST report of about a year ago, the Advanced Manufacturing Partnership, which was spawned out of that report, led by Andrew Leveris and Susan Hockfield, which has really four main thrusts. It has technology, facilities and infrastructure, education and training, and of course policy. So within our purview, what we try to do is to sort of identify keystone capabilities and technologies that would represent the central ecosystem, if you wish, the center of an ecosystem on which we could depend on to spawn these new technologies. Now, the Department of Energy has a lot of user facilities, supercomputers and so on, and other facilities. But we're also interested in establishing advanced manufacturing demonstration facilities. These are facilities where people, small companies, small and medium companies, but also large companies and other entities can come in and actually carry out manufacturing-related research, development, and demonstration, so that they can reduce the risk of new technologies before they make the investments into plant and equipment. This is a way to accelerate, to increase the cadence, if you wish, of deployment. These facilities are there to provide a non-competitive environment where proprietary and non-proprietary work can occur easily, efficiently, and effectively, that will result in a business plan and a decision, hopefully, to make investments in manufacturing. All of the activities within these manufacturing demonstration facilities will be in the domain of TRL 3 to 6 or higher. So these are manufacturing relevant, production pertinent technologies and capabilities. For example, prototype carbon fiber production plants, prototype additive manufacturing, on which you can not only get the product, but to get some idea of the manufacturing likelihood, the quality, and the projected costs of that component. We also have other issues that we want to address: education, training, some manufacturing challenges. And for those of you that are interested, we'll be holding a workshop on March the 12th in Chicago to talk about advanced manufacturing clusters, hubs, and ecosystems. Let me tell you what we mean about technologies that we want to invest, things that we want to invest in to make a difference. So this is from a good friend of mine from DARPA, and this article in the New York Times, dated October the 9th. The Secretary talked about the difficulty of making predictions, especially about the future. Well, here's one. On the same day, this is what Orville wrote. Now, you saw some version of this earlier today, but the important thing for me in this document is assembly. Not just the innovation, but assembly. Actually making things. This is the manufacturing thing. This is the part where a technology and an innovation creates, and we have Matt Ganz and Susan Furstoss here, both in aerospace. We have an airplane and aerospace industry that essentially got spawned from this. That is the leading exporter in the United States. So innovations, manufacturing innovations, can really dramatically change the world. This is also a chart that the Secretary used this morning. If I had known he had used it, I wouldn't have used it. But you heard him talk about this, about the aluminum story. And the aluminum story is really a fundamental technological story. Around the turn of the previous century, in the 1900s, 1890s, the electrolytic process was born that enabled this transformation in the cost of aluminum. And we've had a company, Alcoa, that for 100 years has been a profitable and a leading company. And technical innovation that has led to a brand new industry, a brand new capability for the world. And you know, some of these technologies that you heard about today, if we can hold on to them for 100 years, I'll be happy. I'll be very happy indeed. So it is possible, and there's multiple examples where technology has been the keystone to manufacturing industry. And I want to define keystone in terms of the biological systems. In an ecosystem, in a biological ecosystem, a keystone species is one that basically dominates the ecosystem, even though it may not be present in abundance. Prairie dogs is a good example of a keystone species. Sea urchins. By their mere presence, they have a disproportionate effect on the ecosystem. You take them out of the ecosystem collapses. So in our charter, what we aim to do is to try to identify not all, because this is a global world, but those technologies that the United States can exploit as keystone foundational technologies that will spur a new industry or reinvigorate an existing industry. There is nothing wrong with that either. It's all of the above. And that's really why we are here today, to understand how we will make domestic manufacturing a key part of the future. So the key questions that my fellow panelists have agreed to share with you really relate to these questions. What are the key barriers to domestic manufacturing? Why is it that with all this wonderful research at Office of Science, NSF and other places, why is it all these wonderful innovations that we create all these new ideas? Why do they end up getting manufactured offshore? Why is that? What are the key barriers? And specifically, we have here people from small companies, and large companies, and the investment community. What are the real-world factors that affect that decision? In my case, I suspect every case is different, and every case has to stand on its own merits. But are there common themes across multiple domains and multiple areas, application areas, where there are common factors that we could work together? And then I talked about what is the role of technology. What is the role of our communications infrastructure, for example? Does that give us an edge? What about our university systems? What about the ecosystems that result as a consequence of small companies around universities or other state and regional clusters? And then finally, what role does policy play in reinvigorating American manufacturing? This is a tall order. I propose that we get as many of your questions and we'll try and answer them. This is being recorded, so we will have it. So without further ado, let me go ahead and introduce the panelists, and I will give them the opportunity to tell us a little bit about themselves and what they're interested. First is Furstoss from General Electric. Second is Matthew Ganz from Boeing Aircraft Company. And Atul Kapadia from Envia. As you know, they had a big announcement yesterday. So congratulations on that. And Sohn at the end from MEGE Associates. So without further ado, I will ask first Christine to say a few words.
Great. Well, thank you, Leo. Christine Furstoss. I'm from General Electric. Specifically, I work at our Global Research Center, and I'm the Technical Director for Manufacturing and Materials. I have a wonderful team of about 450 researchers who are working on new innovations in manufacturing and materials. In addition, I work across the General Electric company to work with our supply chain leaders, with our engineering leaders, to think about the strategy and innovation for the company in these areas. And I'd just like to make a few comments. Specifically, I'd like to build off with the comment that Secretary Chu made this morning as he opened the session, saying that we really need to understand how do we change the learning curve. And for me, when I think about domestic manufacturing, when I think about what are the barriers, for me it's about how do we change the learning curve in the efficiency of innovation for manufacturing, specifically for the energy sector. When we think of the energy sector, I think that immediately conjures up innovations that will occur as we think of new ways for energy storage, as we think about changing the equation for the power balance, as we think about how do we make materials that are more rare earth free and also get the kind of performance that we need. But when you start to think about what are some of the real issues, to me, it's that it boils down that as we look at new areas of energy innovation, these types of materials, these types of processes, for the most part, don't follow the traditional cost and scale equation that we're so familiar with in manufacturing. That it's not a simple equation about the pounds of material, about the size of the process. We start to think about processes such as thin film deposition, additive manufacturing, laser joining, composite processing. All of these require a totally new ecosystem. And I'm thrilled that the Department of Energy is going to be promoting new ways of thinking about our ecosystem, because for me, this is really what boils down to the barrier for growth of domestic manufacturing jobs. If we think about the ability of an innovator to work with a small and medium enterprise, to integrate the small and medium enterprises into a very, very complex supply chain, it really will require a new type of ecosystem. And we need to drive new sorts of interactions around the equipment that we need, the type of servicing that we need, how will we balance risk and reward, what is the legal structure and the legal framework as we together try to grow. We need to drive the discussions around critical priorities, critical technologies, in order to grow the entire bulk of what is needed to really advance these technologies. If the innovation around the fundamental systems and materials is occurring in a country, I would contend if we give the long-term priority, the long-term discussion to key manufacturing technologies that are going to be needed to advance this, we will grow that ecosystem. We will grow the people who understand how do you scale very intricate raw materials. We will grow the ecosystem around the people who will make the machines. But we need to set that long-term vision. We need to set those priorities. And then it's going to take every player, whether it's industry, whether it's government, national labs, universities, to step up and to say, how are we going to innovate differently? Today, we're very sequential. We design something, we choose the material set, we determine how to manufacture. We need to change that paradigm. And to me, if we can set up centers, focuses, priorities, incentives to drive more collaboration, to make that a non-sequential process, we're going to change that learning curve.
Thank you, Kristen. Matt?
Thank you. As Leo said, I work for Boeing, and we're the largest exporter of manufactured goods in the United States. And my organization is Boeing Research and Technology, which is the central R&D organization that supports both the defense side and the commercial side of Boeing. It's about 4,000 people on a budget north of $1 billion. So we do, as I said, basic research and development supporting the product lines. We try, inside BR&T, we try to work on technologies that are common to both the defense side and the commercial side of Boeing. And about, I guess, 3 years ago now, we decided that when we looked for those common technology, there were two areas in particular. One was materials and one was manufacturing R&D. Where we thought there were great opportunities to capture synergy across the two sides of the business. So by definition, we moved all the people in the entire company with those two skill codes into BR&T. So if you look at our portfolio, it's heavily weighted on manufacturing technologies and materials technologies, which are of course, a key subset of manufacturing technologies. When you look at Boeing as a whole, we have about $1/3 $1 trillion in firm fixed price backlog. So that number, it's I think about it every night as I fall asleep. There is, and I told our CEO, there's no more important set of technologies that we can develop than those for manufacturing and assembly, because just in simple economic terms, as the accountants would say, it changes the cost of goods sold into earnings, so obviously manufacturing is high on my list of priorities. And as Leah said, it's both the fabrication of parts, the technologies that you just heard about, things like direct digital manufacturing, trying to produce individual parts more efficiently. We sometimes call it the buy-to-fly ratio. There's a tremendous amount of waste if you, for example, buy a huge ingot of titanium and then machine away 95% of it, which we often do today. So finding technologies like additive manufacturing where you can build the part without the waste is key. And then assembly. We drill at our Everett factory. We drill 1 million holes a day. So as you might imagine, it's a very expensive process, and also if you misdrill a hole, for example, the rework is extraordinarily expensive. Typically, every time you misdrill a hole, it involves dozens, if not hundreds, of hours of engineering rework just to correct the mistakes. So the technologies that allow us to do what sound like mundane tasks, but like precision drilling of holes, making sure that they're of sufficient quality, is just critically important to us. We also, inside Boeing Research and Technology, we have a global research organization, which is something that really makes my job fun. We have research labs in Madrid and Moscow and Bangalore, Australia, and Beijing. And having that global visibility really helps give one perspective on all technologies, not just manufacturing technologies, but on American competitiveness in particular. And just a couple things that really concern me as I look around the world. The rest of the world is really stepping on the accelerator with respect to STEM education, and they have very logically well laid out plans. They're hiring a lot of professors from American universities. They're investing tremendous amounts of money. At the same time, our national debate seems to be sometimes headed in the opposite direction. And then also, I have concern when I look at U.S. universities. We still have the best universities in the world, but the immigration policies make it extraordinarily difficult for us to hire the world's best and brightest. And it's just a shame to see such talented people and then not be able to hire them. So I think the final thought I want to leave here, when I look at the national manufacturing initiatives, I hear a lot of analogies being drawn to the semiconductor industry, and a lot of comments that say something to the effect of we should mimic that model, that we want to separate design from manufacturing. And I think you have to be careful, because that works well in a product like semiconductors where it's a photographic process. A 747 has 6 million parts, 3 million of which have a serial number. There's just, we live with separated design and manufacturing, and we're hindered by it. So I think manufacturing initiatives that focus at trying to more tightly integrate the design process with the fabrication and assembly process would be huge. I mentioned misdrilled holes before. We have hundreds or thousands of instances where we have a perfectly engineered part that can't be assembled because you need access someplace where that's physically impossible to reach. It sounds like a mundane problem, but I think developing the engineering manufacturing tools that support assembly on the shop floor would be a key set that maybe we can circle back to.
Great, thanks. My name is...
Thank you, Atul. Thank you.
All right. My name is Atul Kapadia, and I'm Chairman and CEO of Envia Systems. We are a small company based in New York, California. We make innovation in lithium-ion battery materials and actually make lithium-ion batteries. I was asked not to bring any PowerPoints, but I was not asked to bring any cells, so I have a 400 watt-hour per kilogram cell for you guys. It's interesting to note the first two panelists had certain themes in their initial remarks. And even though we are a small company which has mostly seen innovation behind us and see manufacturing ahead of us, we resonate with some of the things they mentioned. We think that the main bottlenecks for manufacturing in the U.S. are, number one is cost. For a small company where cost of capital is pretty high, cost is a pretty high significant bit here. Second is talent. We are in the lithium-ion battery space. While we have some sporadic activity in the lithium-ion battery industry in the U.S., domestically, we don't see a lot of success stories. Unfortunately, in the past few weeks, we have seen some negative stories. What that does is that discourages engineers in schools and universities not to enter this space. Coupled with that, the immigration policies, it makes it difficult to hire talent from abroad. On the other hand, the lithium-ion battery industry has been fledgling in Asia Pacific and some other countries. And so it's easy for us to set up a center in foreign countries to make these lithium-ion battery cells. Number three is capital. I don't think that these three panelists will share that sentiment with me because the cost of capital for their corporations is significantly lower than for ours. We are a venture-backed company. We've had 3 rounds of financing. We've raised $28 million. The last round was $17 million from General Motors, Asahi Kasei, a Japanese chemical company, Asahi Glass, another Japanese chemical company. Now, the cost of capital of borrowing from the strategic partners is arguably lower, but the cost of borrowing from Sand Hill Road venture capitalists is astronomically high. We cannot use those dollars to deploy in manufacturing. So what's prudent strategy for us is our Series C strategy that I just discussed, which is to build good partnerships with the right industry players who do not have an existing play in this space. If they do have an existing play in this space, then there is an intellectual property problem that we need to solve. Those problems can rarely be solved contractually. They have to be solved by trust. Trust is not easy to build across the oceans and continents without having past working history. So those are the three considerations. The fourth is public sustained will, which is we've been talking about manufacturing at no end. Last year we had a Brookings panel talking about manufacturing. I'm sure there are tens of panels in between last year and this year. But still we haven't really done what needs to get done, which is establish centers where there is less regulation, less taxation, all the policy things that can be done to implement or encourage corporations like us to enter manufacturing and even encourage the larger companies to enter manufacturing in the specific sectors. So I just want to summarize. For us, manufacturing barriers, number one is cost, number two is talent, number three is capital, and number fourth is public will. So what did Envia do to make these batteries? Because Envia is not only an intellectual property player, it also makes these batteries. Well, so what we did is a compromise. With the limited funds that are at our disposal, we decided to set up the battery materials plant, which is the intellectual property sensitive plant in Fremont, California, or Newark, California. Yes, it would have been much cheaper for us to set up that plant in Asia Pacific or some other countries, but we decided that there was a trade-off, and it was a fuzzy trade-off. Intellectual property in the materials is much more important than intellectual property in the cell itself. The cell, at the end of the day, our vision is just a system integration play, like the Dells, the Compacts of yesteryears, or the Gateways. The materials is really where the intelligence is. And that's what Intel did in the late 70s and early 80s. 70% of the cost of the cell is in the cathode, the anode, and the electrolyte. So we make the cathode, the anode, and the electrolyte at Envia in California. But as I said, the cell is mostly a system integration play, and we set up a China cell development center in China, Jiaxing, where the cost of setting up that center was a fraction of what it would have cost us in Newark, California. And what we do is we have very clean boundaries. We ship the material from Envia USA to Envia China. There is no material analysis happening in China. All they do is take these materials and assemble it into a cell. Number two, we have an American gentleman who was educated in America, who worked in America for many years, but is an American Chinese national who runs our CDC in China. So we think that culture of respecting intellectual property has to be brought from here to there. I shouldn't be talking about why we should manufacturing in China, but that's what pragmatically we have done, right? Those are my comments.
Thanks, Atul, and thank you very much for inviting me. It's an honor to be here. And although I'm currently doing advisement and and type of work. My background is in manufacturing, having worked many years at Intel and then First Solar and most recently at Fluidic Energy in Phoenix, Arizona. I want to use my moments here to talk about an occasion I had about a year ago when I was leading the Manufacturing Council in the Department of Commerce. And we were having a meeting, and it was kind of a think tank sort of session, and the purpose of the meeting ostensibly was to answer these questions. What does it take to enhance manufacturing? What are the barriers to manufacturing in the United States? And there were a couple of dozen executives, all CEOs, presidents, COOs, the decision makers in these companies for deciding when and where manufacturing facilities would be made. And this was a cross-section, some very, very large companies, some very tiny companies, East Coast, West Coast, high-tech, and some older technologies. And we had spent a significant amount of time, in fact several meetings, putting together some recommendations, and we were kind of towards the end of writing them down and putting them into a form that we could actually hand to those who had sponsored us. And following a break, we got back together, and I decided to pose a question to the group. And the question was actually quite simple. All I did was I said, let's pretend for a moment that we take all of these recommendations, and these weren't anything earth-shattering in terms of the recommendations. They're very familiar, the kinds of things that have been discussed here in regards to tax policy, cost policy, labor education, regulatory issues, repatriation of funds, all of those sorts of things that factor into the typical sort of discussion. And I said, let's pretend for a moment that we hand these over to the folks and they take it to Congress, and somehow they manage to pass it exactly the way we wrote it. And then it goes to the White House and it gets signed into law exactly the way we proposed it. My question is how many of you, as the decision makers in these companies, are now committed to make more investments in manufacturing in the United States? And I actually went around the room asking that question of each person. And of the about 24 people that were sitting in the room, not a single person was willing to commit that their company would categorically invest more in manufacturing in the United States as a result of all of these recommendations that as a group we had just put together. Which forced me to rethink about what it is that goes into making a decision when it comes down to actually signing on the dotted line and putting a factory in any particular location around the world. And I found myself asking exactly what happens. So when we were citing the various manufacturing sites at Intel, or when I was considering them at First Solar, where and what were we actually talking about, and how was that discussion happening? And what I started to realize is that there was a fairly significant difference between the way we were going about the decision-making process when we evaluated in the United States and what was occurring in the rest of the world. In the United States, we would find that one state, California, Texas, New York, whatever, would come together and they'd say, well, I can do this better than another state, and I can do something else that would be even more attractive than they would be. And we would go and we'd plug these numbers into a model, and it would look pretty good. It would be kind of interesting to see how these states would compete. But what I came to discover is that if you took all those numbers that all of those states were talking about and you zeroed them out completely in our Excel spreadsheets, it still didn't compare to the deals that we were seeing coming out of places elsewhere in the world. And I'm sure you're thinking, well, these are all in Southeast Asia, the Chinas and Vietnams and Thailands and Malaysias and so forth of the world. And yeah, those are the places, but we saw the same sort of situation in both Eastern and Western Europe as well, where countries were willing to sit down and say, I want your industry here. I not only want your industry, but I want your company to build its factory here. And they saw a bigger vision for what this meant to their region. And they were willing to do whatever it took to figure out how to attract our sort of industry there. And a lot of it ended up being financial sort of situations, but some of it wasn't always the financial things. But these are a big deal, and these are things that affect us at the federal level, something where we can't do a deal in the United States. And it's quite significant. If you run through the numbers, for example, investing, say, $250 million or so in a factory that generates maybe $250 or $300 million of high-tech products, something that's maybe 50 or 60 percent gross margins, and you look at the net present value of that factory if you site it in the United States versus siting it in a low-cost geography, and you'll actually find that there could be a $250 million difference in that net present cost simply by running through the numbers currently as they stand in America and elsewhere in the world. $250 million on a $250 million investment. A CEO cannot deny that to his or her shareholders when they sit down and they go through that decision-making process. They have to consider those things. What we're lacking in the United States fundamentally is the right kind of leadership that allows us to sit down and make a deal. The kind of innovative capitalism that is required in order for us to say, this is important to America. We need at least 15% or perhaps more of our GDP going into manufacturing. We need that leadership, and we need to have the flexibility to figure out how to say, let's make a deal. I want that technology in the United States. I want that company to be doing it in the United States. The right answer should be to do it in the United States. We can't have policies and mechanisms in place that are counter to the way it really should be done. In other words, the right answer for that CEO is that she has to be able to make the right decision for her company.
Thank you, Bruce. Well, we've heard some interesting comments from our panel, and I want to make sure that I open the discussion to both to you here in the audience and on Twitter, to the folks watching us. But I did pick up a couple of things I just want to follow up here. It is clear to me, at least, that we cannot be in manufacturing of everything, and that we have to be strategic in what happens. But there are some areas where there is I think, consensus that the United States has an edge. And we've heard one specifically, and it was called IP protection. So it was quite startling to me that a positive decision was made that we will cite the materials and other intellectual property-rich aspects in the United States because that's the best deal, but we'll leave assembly to China. And I think as a nation, we need to understand what our strengths are and build on those. If assembly is not our strength, at least for some things, I think it probably is for others, then we need to sort of identify that and focus on that. So another item that seems to be coming across the panels, and I've cited a number of this so far, is this idea of an educated workforce, the STEM, so-called STEM issues, but probably training and retraining as well. I'd like to ask you, Matt, first. I mean, as a multinational company, what's your take on both IP and the workforce issues?
I think those are both near or at or near the top of the list. Certainly, we share the same IP concerns where we globally source our products from nearly every country in the world, and so we screen our intellectual property. We have dozens of hours of meetings every few months on intellectual properties, trying to figure out exactly what is the critical proprietary information, and absolutely make our make, buy, and our must design decisions based on intellectual property, and keeping the critical intellectual property here in the U.S. For obvious reasons, but. The STEM education is clearly a big one. I mentioned before the frustration of seeing so many bright people. One of the best engineering schools in the country, one of the very best couple schools in the country, the dean came to me probably a year ago and said, every year one of our students is the best student that just shines above the rest. And he says every 5 years you get a student who shines above those other four. And he said, this student's it. And he said this student's aerospace engineer goal in life was to work for the Boeing company. and he's probably from one of the countries that is among the 2 or 3 friendliest countries to the U.S. And it has just been a nightmare trying to hire this person. There's just, we've appealed there's just no place to appeal the decision based on common sense. And if we do hire them, it's going to have to be through a complicated exception, hiring them overseas, out of sight, out of mind for a few years. And if we can still keep them interested, then perhaps bring them back. And I echo Bruce's comments. When you go overseas, and it isn't just Asia, there are countries like England who are very interested in manufacturing. They have depressed economic zones, and they put extraordinarily attractive financial terms together for just manufacturing research facilities. But it's more than just the money. You get the buy-in at just the most senior levels in the government, and they come to you saying, "How can we help Boeing?" They don't, it isn't here are the rules, and if you pass the rules, you can build your factory. It's, what is it? What can we do to help you say yes? That attitude means a lot.
Christine, do you have a comment?
Yeah, a couple of comments. I would echo what our panelists said, and I love the discussion with Bruce about how do we compete today when in many cases we're not competing with another company or one side. We're competing with the whole country. And are we setting the right priorities? So I want to get back to, it is about setting the long-term vision, making the value choices. Everything in life is a value choice, and where we invest even for large corporations, because we have to answer to our stockholders, you got to look for scale, you got to look for that value and that differentiation. And so when we talk about intellectual property, again, I think if we understand that we're going to be the best in deposition technology or composite technology, and we can really rally around that with our partners, with our universities, with our national labs, with the small and medium enterprises, we can start to drive the types of thought processes, the types of scale. And there's enough intellectual property for all, but we have to protect it, and we got to make sure that that's going to differentiate us. Now, I speak with a lot of small and medium enterprises because I am trying to grow this infrastructure and understand that as we drive innovation, we're going to have to drive all of the growth around us to really make it happen. And being able to hire the best and brightest isn't just an issue for General Electric or Boeing or small. It's everywhere. It's every company, the 10-person company, the 15-person company. It is about STEM education, but it's also about how we think about the value of manufacturing. And as you make trade technologies, as you make the types of real scale technologies that we're going to need a national priority, it'll be okay to go to those types of schools. It'll be pride to have that type of role. And I think we need to regrow that in America.
Can I address the... Yeah. So I just want to address a little bit about the talent pool. We don't find a single problem in hiring talent pool, good scientists and good engineers from American universities. I still think even today, even though China is publishing more patents, filing for more patents and being granted more patents, I think the American universities are bar none the best universities in the world. I came to U.S. to study in an American university, and I'm thankful for that. So we don't have any problem hiring scientists. There's a great pool of researchers and scientists in the U.S. Where there's a problem is in hiring experienced lithium-ion battery engineers. My comments are going to be very narrow and very specific to the lithium-ion battery industry for automotive applications, because that's all we do. For example, would we hire a person from NR1? Would we hire a person from A123? I don't know. We are looking for that ecosystem and that vibrant value chain in the lithium-ion battery industry in the U.S. to be able to hire those manufacturing engineers. The second question was made about intellectual property. So, we live and breathe intellectual property at Envia, because for a company of 35 people, barely struggling to stay alive, and yet achieving a 400 watt-hour per kilogram battery, intellectual property is everything. We've filed about 30 patents amongst the 36 headcount. And we could have, if it was a cost-optimized decision, that decision to make those materials would probably have been in China. But because IP is such a big driver of a small company, that's why the material is being made in New York, California. when you have a large company with several portfolios of products in there, and intellectual property on any one product is just one consideration, I don't know if that decision is optimized based on IP or decision is based on cost. Maybe some of the panelists can share their experiences on that.
I just had real quick. So when it comes to IP, we often talk about the impediments to manufacturing. The rule of law in the U.S. is obviously a real enhancement for why you want to do manufacturing and innovation in the United States, because we get into all of these discussions and nobody ever says, boy, the U.S. is a bad place. I mean, it may be a challenge, but the rest of the world is a whole bunch bigger challenge when it comes to IP. And when it comes to education, I think that there's really two specific things that we could be doing dramatically more with. First off is that when you get somebody that graduates with a engineering degree of some sort, regardless of where they're from, if they're from out of the country, we should just hand them a green card with their diploma and be done with it. And then the second thing is that we've got to encourage our younger people to get into manufacturing. Every time I have taken somebody that was in junior high or high school and walked them into any factory, and I don't think it matters what factory it is, they look at it and it's just a jaw-dropping sort of situation for them. They're like, wow, this is really neat. I didn't know manufacturing was so cool. And they get inspired by that, and that gets the creative juices going, and hopefully we end up with a few more engineers as a result of that. And if all of us in the room would somehow go out and find one class in our area and bring them into our facilities, whether it's R&D or manufacturing, my guess is that America would end up with a whole lot more engineers in the future and scientists.
With no manufacturing jobs.
I could not agree more. And in fact, I made a note in my travels through and talks when I talk to universities and schools and people, I tell them this is a call for action in manufacturing, just like the moonshot was. And what I want everybody to be thinking, just as in the 60s everybody wanted to be an aerospace engineer to go to the moon, I want everybody to aspire to be a manufacturing engineer, because manufacturing is exciting. And I think it's all up to us to sort of engage the community. And this is not your grandfather's manufacturing. This is not the Industrial Revolution of the 19th century. This is 21st century. This is clean, or it can be. It's clean, it's smart, it's innovative, and so on. I would like to encourage questions from the floor. Would you please use the microphone, or if you'd like to ask a question, you can maybe make your way to one of the microphones.
Wow. Hi, my name is Ed Carapez. I'm with General Atomics. One thing would be interesting to get comments from the panel on. I've been reading articles in the last year about U.S. companies that are bringing their manufacturing back to the United States. One example that I remember in the last 2 or 3 months was United Technology, manufacturer of Otis elevators, made a corporate decision to bring their manufacturing back to the U.S. from Mexico. The article talked about a few reasons, but one of them that stuck in my memory was the fact that they just found they could produce a better product by locating their manufacturing facility near their design house. So to have their engineers be able to work closely with the manufacturing team, they felt they could produce a better, more cost-effective product. So in this panel, I would think that it would be nice, I think, Bruce, it's your name on the end, right? Yeah. You had talked about all the economic disincentives for companies to manufacture here versus overseas. It'd be nice to try to pick your brains on looking at the case studies where people have made corporate decisions to come back. Or maybe GE has, maybe Boeing has, I don't know. So that's my comment. Here.
I have 2 examples which I think address what you said. We recently have moved a number of manufacturing jobs from offshore back to Louisville, Kentucky for our appliances business. And it's around understanding how to drive innovation faster. You know, in today's market, there's so many new products a day. There's so many different price points that you have to pick. both Matt and I had discussed about how we need to understand how do we better drive manufacturing development back into the design development. So it's no longer that sequential process I mentioned, but really letting manufacturing innovation drive what our new designs are instead of entirely vice versa. And both for scale issues, for the ability to rapidly innovate, we've brought our much of our appliance manufacturing and have grown our Louisville, Kentucky facilities. Secondly, we have launched a new product called the Durathon battery. It's an energy storage battery. It's a sodium metal halide. It's a energy, not a power, so it's not a lithium-ion type of battery. It's used in the utility sector. It's used for backup power. It was developed based on a number of technologies that were acquired worldwide, but integrated in large part at the research center in upstate New York. Our manufacturing facility is being built 5 miles from the research center. When at full scale, it'll employ 350 approximately new manufacturing jobs. It's starting to come up to speed now, and I will tell you my researchers are on that floor every morning for just the reason you mentioned. So it does happen.
We have a Twitter question.
Yes, it was in the long term, isn't U.S. manufacturing mostly a dollar strength and energy cost issue?
I'll just mention on the energy side, predictable energy costs are a huge part of it. Being able to make the kind of trade-offs and understand what the long-term energy rates, energy prices will be is a very critical part of the manufacturing equation. I'm sure there's other thoughts.
I think it's also it's a skilled workforce issue, and again we've reiterated several times the value in having, Ed's point, the value of having engineering co-located or very closely located to the factory floor. And if you've got the engineering capital here, then it makes sense to have the manufacturing closely co-located. So, and I think there's a myth that there are, that the manufacturing jobs aren't out there. There's actually, I think if you look, there are a lot of good manufacturing jobs that are open right now. I think the difference is, I think the manufacturing jobs of the future will be much more, they'll require some post-high school education. I mean, you need, these people are going to be working with, very expensive and very complicated pieces of machinery very often. So it's going to take probably a little more training than the manufacturing, the typical manufacturing job of a few years ago. But there's another case where the U.S. has an advantage.
Well, I'll just take just to take off on that. I just want to highlight one group of people, like our veterans coming back from the wars. These men and women have, even if they don't have a full post-high school education, they've been trained in the most sophisticated equipment there is out there, night vision, targeting systems, and so on. It's highly skilled individuals, and I think as a nation we need to sort of exploit the tremendous resource that we have in our people there, and to also acknowledge our indebtedness to them and our gratitude to them for their service. So, I mean, that's a place, I think, where people get trained under the most brutal conditions, quite frankly, difficult conditions, and have a skill set that's bar none.
I actually wanted to couple to the Twitter question, though. So the concept of this being an energy issue, I actually don't think that that's a big deal when it comes to manufacturing, especially as it's related to transportation. Frankly, energy is relatively cheap. So long as we'd have no price on carbon, it costs almost nothing to move pretty heavy materials all around the world. We heard, for example, the discussion about being able to manufacture transformers. It's got to be one of the heaviest products made in the entire world, and we make them on the other side of the planet and ship them over here and don't think about it at all whatsoever. And in regards to the value of the dollar, certainly it would have to do with a currency valuation, but who wants to wait until the value of the dollar's dropped by 50% or something for us to react? There's a matter of latency and so forth, and we need to be proactive and have some vision and leadership around this.
Thank you, Leo. If I may tie together a few threads from, Leo, your comments, Christine's and Bruce's, to touch on an aspirational suggestion, but also a cautionary note. Leo, first, you have extraordinary opportunity to incent manufacturing in the U.S. with renewable chemicals and advanced materials. I would suggest the U.S. has a competitive advantage in this sector. But if we allow this sector to suffer benign neglect with lack of government funding, it will wither and die here and take root abroad. And Bruce, to your point, these nascent but fast-moving companies, dozens of which just filed S1s, and a few have had successful IPOs, when other sectors, particularly renewable and energy efficiency, are dampening. They're competing for site selection with the states trying to pull together incentive packages in California or South Dakota or Iowa or Kentucky. They're competing against sovereign nations, Thailand, Indonesia, Canada, Poland. So your advanced manufacturing program today can provide critical short-term stopgap funding to incent CapEx here, and then growing out the full value chain, which is upstream to the farmers and the seed and the Monsantos and the Cargills, to the manufacturers, to the converters, to the brand-facing downstream customers and everyone in between. And then finally, why DOE should care beyond EPA's green chemistry or Commerce, NIST, or USDA, orders of magnitude significance in energy efficiency, and that number you showed about industry consuming 30% of energy, greenhouse gas reductions 50% and beyond, and for one instance, biodipic acid is 250% more efficient than incumbent state of the technology, petroleum-based adipic acid. And this speaks, Christine, to your comment about we can design at the molecular level for a full systems and value chain end result. That's good for America. And if we don't do it, then we're going to have a case study 5 years from now saying, why did everyone go abroad? And that comment, I think it was Bill Gates, or no, I'm sorry, it was Walmart's CEO who said, we're not going to bring men's underwear back from Guatemala. Well, we don't want to have that same comment about this advanced manufacturing sector that is unleashing innovation in graduate students across the country and undergraduates. So thank you.
Thank you. Thank you. Kimberly?
I have a question. We've talked a lot about several innovations that each of you in your own industries would like to see. I want to hear a little bit more about what do you think I think Leo started out with the right thing. What's the innovation ecosystem that you want to see that can best foment the kind of innovation that you're looking for in each individual industry sector? So what's the innovation ecosystem you're looking for? What are we missing today in the U.S.? What can we do better at, and what are we really great at?
Well, we are missing, for Envia, we are missing, as I said before, a successful lithium-ion battery company. We have several of them, but none of them have been successful. Some of them have raised hundreds of millions of dollars from public and private funds, and nothing's come out of it. The fundamental foundation of any lithium-ion battery company is an array of scientists and engineers. It's a material scientists, electrochemists. It's an interdisciplinary team like Envia has. And we're able to get them, as I said, from the universities. University of Delaware, University of Rhode Island, MIT, Stanford, Berkeley. That's our team, right? So that's fine. But then you go to the next level, well, we've got to scale up the material. And you're right. We have to scale up the material close to where the innovation is happening, so that the guy who's scaling it up, we talk in terms of guys, we don't talk in terms of 500 people organizations, so I'll stay at that level. The guy who's scaling the material up and the two guys who invented the material or did the experiments to figure out what the right composition is can talk to each other and make sure that that cycle is accelerated. That works fine. The next step up is to buy the equipment from Japan, the big equipment, the furnaces and the reactors from Japan and US, set them all up. Well, site selection becomes an issue. Yes, you can have the states competing for their sites, but at the end of the day, it's the taxation from the federal side that really there really is an imposing thing. And the regulation, of course, from the state, county, and local side, but it's the combination of that regulation. We'd love to get some successful lithium-ion battery companies around, because then we can talk to each other, we can form partnerships, compete in the markets, and make each other better. Right now, as somebody else said, we are competing with Korean companies, Japanese companies, and European companies, not with American companies. And that's a pity.
Yes.
Thank you for your time. My question is towards the larger companies. People talked about choosing where to, engineers, when they're choosing jobs after they graduate from school, I know a lot, and it's been an issue that's discussed, that maybe they won't go into engineering, because when they're looking at some of the bigger jobs, it's not really the money, but the opportunities for growth. They feel it's better if they choose a different field, and people will go to finance or consulting or outside of engineering. Sometimes they'll go to startups, but not always. I was wondering what some of the larger companies are doing to, incentivize engineers to stay within the field, wherever they happen to be.
Well, I think you raise a good point. And to go back to the ecosystem question, I think we have an industry, university ecosystem that works pretty well. I think the government is a partner at that table, but often just bureaucratic rules make it a difficult partnership. But I think there's a fourth element, and that could be the cultural element of engineers. When many of us grew up in the room, watching Gilligan's Island, and the professor was our real hero, right? And in today's popular culture, the engineers are the Big Bang Theory, and so I think there is an element of trying to. I know we at Boeing in Los Angeles are working with the entertainment industry and talking about that very issue. But we're also reaching out to our younger employees and really trying to listen. They do, or I should say our newer employees, they do think differently, and we're trying to bring some of the tools that the Twitters, the social networking tools that they're used to. So we're trying to listen, we're trying to reach out. We have reinvigorated our mentoring programs, and we're picking relatively new employees that have high potential, and personally, grabbing them by the arm and pulling them up the org chart.
Yeah, so I am an engineer, and I've been 23 years an engineer. And there's been lots of opportunities. As you look at today's workforce and the people entering the workforce today, it is a different mentality. I have a 14-year-old son, and I know his level of expectation of advancement, and some people say it's driven by the video games and leveling up, and there's just an expectation. It is what it is in the world today, no matter what the cause. And so at General Electric, we are relooking and have relooked at our advancement system. The way I like to talk about any kind of career, it's really about growing your sphere of influence when you get into the professional career. So when you start your career, your sphere of influence is essentially you. People are telling you what to do, but are we really giving opportunities in the engineering and sciences and manufacturing trades for people to grow their sphere of influence, to have an impact, to get more responsibility? And so we continue to invest in our human resource and leadership training to make sure that not only do we recognize that people, if they earn it and then can perform, want those opportunities, but that everyone from the top down is thinking that, and we're trying to lead by example. I don't know the answer yet. I don't have the full answer. But we recognize that in today's world, the expectations are different, as they should be. We haven't changed them really in a number of generations, and we need to now. So I know that a number of large corporations, besides General Electric, are looking at this, but there's no easy answer yet.
I want to take the liberty of being the chairman here and sort of throw in some things, because I think, what I like to sort of lay out to the group and think about it is we encourage our new generation to get into engineering. We have to talk their language, and we have to allow them to rethink the processes that we have put in place for themselves. just like the sixth generation, I guess, changed the way that we think, they should have the same opportunity. And in the manufacturing domain, I think we need to look, personally, I think we need to look at fundamental things that we do and say, we've been doing them this way for some time. Why? Why are we doing them? I'll give you an example, a field that I know very little about, so I'm qualified to talk about it. This is about the separation of liquids. So if you go down the Gulf Coast or the Northeast or wherever, you see all these distillation columns. And what are they? I'll talk to it in the context of energy. What is the function of these distillation columns? Liquids that are going to be separated, materials that are going to be separated. And how do we do that today? Today we take that mass of liquids, we heat it up, CPM delta T, then we give it the latent heat of fusion, evaporation. That's a lot of heat, it evaporates, separates, condenses, the heat goes away, energy wasted, and then we've separated it. Yet in this room, as we sit here today, billions of separations are going on at room temperature. They're going in your body, in your membranes, right now. They're going on right now. So it's happening at 36.8 degrees centigrade. Okay? So why can we not use separation technologies using membranes? Rethink the separation problem completely. Now, are we going to take all the distillation columns away tomorrow? No. There's a lifetime capital cost. But we need, I think, to get those kinds of innovations and those kinds of breakthroughs in a way that are energy efficient, sustainable, without the generation of greenhouse gases. And I think for those of us that have some leadership role, like yourselves, that's why you're here today, in your companies, in your organizations, we need to encourage our young people to think boldly like this, different in this kind of way, and to allow them to fail occasionally. It's the fear of failure that stops us from doing things. It's the fear of failure of putting in a new material that might bring, God forbid, an airplane down. That's the fear that stops us from doing things. So I'm not suggesting that we're going to take risks, but I'm saying for our young people, our engineers, and the innovation, we need to encourage that, and it's up to us to do that. So that's a plea from somebody who's been in the field.
Leo, just 1 second. Anybody who has kids knows that you can't tell them really what to do. They do what they really want to do. And you can't just say, I'm encouraging you to become an engineer. I think that engineers or professions are not chosen out of percentage raises that are granted by large companies or the compensation schemes. Professions are chosen out of icons. My daughter wants to be Taylor Swift. My other daughter wants to be an astronaut. And the reason they want to be is because they admire somebody who's an icon in that space. A lot of kids today want to be Mark Zuckerberg and go and make Facebook. I think the real heroes are my CTO, for example, Dr. Sujit Kumar, who invented the material here. Until America gets into that culture mode where hardcore engineers and scientists become icons, you're not going to be able to tell your kids to become engineers. They will follow their destiny based on what they read in the newspaper or the blogs, etc.
Well said. I'm Bill Acker from New York Battery Energy Storage Technology Consortium, and I'd like to follow up and explore your thoughts a little bit more on the non-sequential product development through manufacturing, and particularly with respect to laboratories and other institutions outside of your own R&D laboratories. So I think, Christina, you mentioned the idea of some sort of center or other ways of pulling in outside resources into these things. So I'd like to explore those ideas a little bit more and understand the importance of engaging the full ecosystem in that aspect of it. And then the other question I have, and I'll preface this by saying I'm a big fan of the first point, so don't think this is a negative, but it's a little bit of a devil's advocate question, is why is that so important now? When, if you step back 20 years, it's certainly a lot easier for your engineers here to engage with your manufacturing plant anywhere in the world than it was 20 years ago. And yet we're now talking about bringing engineering and R&D together with manufacturing more than we were before. So I'm curious as to what's driving that new view.
From my perspective, two items are primarily driving it. The first is because of the advancements in many of the design tools, so high-performance computing. This morning we heard about simulated fluidic. Designs occur in such a shorter cycle time. And as I mentioned a few moments ago, with global competition, markets that are changing so rapidly for so many myriads of reasons, regulatory, competitive, the ability to have more products at more price points, more performance, and now the cycle time is shorter, is just astronomical. Yet material and manufacturing development hasn't made those same investments. And so they become now, we go for the low risk, we'll get the cost out, go to a low cost provider. That's not going to drive innovation. That's not going to change the game. And so I think that the investments that have been made in the design side without the equal investments on the material manufacturing are really, in my point, what's just now brought it to a crisis point that we need to change. And I think that from, how do we integrate and why do we integrate, again, I think one of the barriers, I didn't mention it before, is the fact that as we try to engage more smaller companies, medium companies, companies with specialized expertise and try to bring them to a new scale, we have to make sure that they have access to the types of computational really needs that we have. Every drawing is electronic now. Every analysis needs to be done real time, and we can't leave a segment behind. So, you mentioned the high-performance computing resources that are available. I just want simple sharing resources for many, many companies. So that's a couple points as to why, for me, it's at crisis point and some of the things we need to do.
We have just about 3 or 4 minutes left, so quickly.
No, I was just going to amplify a point. I think Christine hit it right on the head. It's the cycle times are shorter. The regulatory environment, chemicals get put on the banned chemical list, and you've got to get them out of the product at a tremendously increasing rate. And with the increasing cycle time comes increasing competition. So the big thing is the cost of an error is orders of magnitude higher now than it was decades ago.
And the technical demands, frankly, are geometrically more difficult today than they were just a few years ago, and they're increasing all the time. And a lot of the advantage that differentiates one company from another can be in that gap between their research and development and the manufacturing. You really you can't separate them in the modern world anymore. We all know that there's ways of making things in a laboratory that look really fascinating, but getting that to scale and making millions of those things that operate in the exact same way over and over and over again reliably for years and years and years is a totally different thing. So if you're only thinking of one side of it and you think of it sequentially, it's probably going to take a whole lot longer and create a lot more headaches for you.
Well, with that actually brings me to the conclusion here, because we run out of time, and that's really the thing that I want to leave with this group. Cadence of development and manufacturing support. Controlling for time is key. Fast production, get that to market first. I'd like to thank our panel today for spending their time here and sharing their comments. For those of you that didn't get a chance to sort of contribute and share your thoughts, you can find me on the web, and I will love to hear from you. Any ideas, comments, criticisms. The job that I have is not really to set policy from Washington, but to actually aggregate the knowledge and wisdom of the whole country. We'd like to be informed by you. I can't physically, and we cannot physically talk to every one of you, but we would certainly will respect any contribution that you have to give us. We would gladly accept it, and we'll respect it appropriately. And it will help us make better decisions, I hope. So once again, thank you, panel, and thank you all for participating.